Hello and welcome. Today we are going to solve our fifth problem of Leetcode, that is longest palindromic substring. Okay, so let's first understand what is palindrome. So I have already written down an example of palindromic substring. So palindromic string. So this is a string. We can say this is a palindromic string. If you are reading it from beginning, it will be A, B, C, B, A. Okay, and again if you are reading it from last, it will be A, B, C, B, A. Uh, you can see that if you are reading it from beginning or if you are reading it from last, it is going to be same. So if any string is same on after reading it from beginning and last, then we can say that that's a string is palindromic string. So now we know what is palindromic string. So now get into this problem. So we have given a string and we have to find out the longest palindromic substring. So what are the substrings in this string? B can be a substring, BA can be a substring, BAB can be a string, BA BA can be a string substring, BABAD can be a substring. Any contiguous a string that is driven from this a string is can be referred as a substring. So among this, which substrings are palindromic? So we can see that BAB is a substring which is also palindromic. And length of this substring is 3. Okay. And again we can see that also ABA is also a substring which is also palindromic, and the length of this substring is also 3. Apart from this, there are no substring which have longest length than these two, and we can see that BAB and EABA are two valid results. So now we have got an idea how we can check that, how we can find out the longest substring. So one approach can be of brute force. In this we have to iterate through all the substrings and we have to find out all the substring, and we have to check whether this substring is palindromic or not. So in order to find out all the substring, we have to iterate from I equal to 0 to n, where n is the length of a string, and inside this for loop we have to again iterate from j equal to I plus 1 to or I to n. So we can see that this is going to be time complexity of big of n square for finding all the substring. And after that we have to check whether this substring is palindrome or not. For that we are going to take big of n time. So on computing these two, we will find out the time complexity of this approach is going to be big of n cube. Obviously this is not the optimized one, and I will not advise you to go with this. Okay, so we have to look for some other option, like which will going to take some lesser amount of time. So what can be other option? Let's see. Here we can see that if we are starting from, let's say, right, A B A D. So if we are starting from this index and we are go left and right, then we are not able to go left, and so we have to only consider this B. Okay, so if we are considering this as a middle one or center point, then we can't expand it from left and right. So we are going to use all the indexes as the central point, and we'll try to expand left and right. So if we are at index 1, let's say B A B, if you are at index 1, we will try to expand it from left side and right side. We can see that if we are moving left side and right side simultaneously, then B and B are equal. So the length of this substring is going to be 3. Again, if we are at index number 2 and we are moving left and right simultaneously, we can see that A and D are equal. We can move again, we can see B and D are not equal, so this will not be valid, and but A B are valid substring. So if you are moving from point B, we can move only one distance left side and one distance right side. So the length of this substring is going to be 3. Okay. So in a worst case, we will always find a substring of length 1 which will be palindrome. Okay. So our answer will always be greater than equal to 1. So I think you got an idea how we are going to solve this. So we will try to expand from all indexes and find out the longest substring we can make, which is also palindrome. Okay, so let's say I'm writing another of test case. Let's say it is A, B, C, D, E, D, C, A, B. Okay, so we are like, for instance, we are at index 0. If you are trying to move left side, we will not able to move. So this will, the length of this substring, which is also palindrome, is 1. Okay, so for now result will be 1. Now we are at index 1. We will try to move left and right simultaneously. We can see that left and right indexes, left and right characters are not same, so we will not move forward, and the result will again 1. Now we will move to index number 2, and we will try to move left and right simultaneously. Again B and D are not equal, so we will not move further, and the result will be also 1. We will at index 3. So again we will try to move left and right simultaneously, and we can see that C and E are not equal, so the result will also same, that is 1. Now we are at index 4, that is character E. So from here we will try to move left and right. We can see that D and D are equal. We'll again try to move further. We can see C and C are equal. We will try to move further. We can see B and A are not equal. So till now we have moved from C to C. So the length of this substring is 5. So we will replace our result from 1 to 5. And again we have to store the starting and end index of this substring. So our starting index is what? We can see the starting index is 2 and the end index is 5, 6, 7. So 7. A start is 2 and end is 7. So again we'll traverse further, and we'll be at index 6. Again we'll try to move left and right simultaneously. We can see and C are not equal, so we'll not move further, and we'll come to index 7. We'll again try to move left and right. D and A are not equal. We'll again come at index A, and we'll try to move left and right. C and B are not equal. At last we will be at index B. We can't move right side, but we can move only left side. So we will not move, as we are not able to move both sides in equal size, so we will not move. Okay, and we can see that our result, maximum substring of length is what? 5, and the starting index of this substring is 2, and the end index is 7. So we will return a substring from index 2 to 7, which is going to be CDE DC. Okay, by using this method we can find out our result in big of n time for finding substring, and big of n time for checking whether substring is palindrome or not. So it is going to be a big of n square, which is far better than the last one. Okay, now remove this. Okay, there can be two cases that we have to handle. Let's see what are those two. So we can be at in condition where A, B, C, B, C. So let's see, we are at index C. So C can also be included in palindromic substring, and we can move left and right. But there can be a case like A, B, C, C, B, C. So for finding the longest palindromic, we have to consider these two also. Okay, so we have to, whenever we are expanding from middle one, we have to consider the middle one apart from middle one plus the next index also for this condition. Okay, so let's see how we can solve this. We will be expanding. This is a for loop we are iterating for. It will be from I equal to 0 to n. Okay, and we have to find out the length 1 of, we will somewhere we will make a method function expand from mid, which will going to do some work and return result the longest substring, which is from after expanding the middle one, the longest substring, which is palindrome. Okay, so it will first we have to send I the two middle position, like the first index and the second index, I plus 1. So if you are considering only the middle one, then both the indexes will be I. Okay, and this for second one, length 2 will be I and I plus 1. Whenever we will find that len 1 or len 2 is greater than our previous max value, we will update our max value with len 1 and len 2 and previous max. Okay, and then we will store the starting index and end index of maximum substring. Okay, so this is the rough idea that we are going to solve. Now gets into compiler, we will going to code there. Okay, so yeah, first we have to check whether our string is valid one or not. So if s equal to null or s dot length equal to 0, we will return s or empty string. Okay, now we have to store the starting index and end index. For that we are initializing with 0 and end index is also 0. Okay, now we'll start iterating for loop I equal to 0 and I should be lesser than s dot length I plus plus will. Okay, we are going to call a function that we discussed earlier, len1 equal to expand from mid. Let's declare this function also. This is going to take a string and left index and right index. Okay, we'll write down this function later on. Okay, so this is going to return the longest length expanding from this index, the middle one. Okay, so we'll send the string s and the left index is also I and right index is also I. Len2 will be expanding same from mid, s left index is I and right index is I plus 1. In the case where can, for the case a b c c b a, in which we have to consider these two as a middle one. Okay, for that we are using the len2 where I and I plus 1 we are sending, and for the case where we have to consider only one middle element, we are using len1. Okay, I think this is clear now. Till now it's okay. We have to also initialize the len. I don't think so. Yeah, so len there will be another variable len equal to math.max length 1 and length 2. If you will find out that a sorry end minus a start is lesser than len, in this case we'll update our start and end. So what can we start? So we are expanding from middle, so this equal amount of indexes will be traveling left side and right side. So a start can be I minus something, which is going to be len minus 1 by 2 for the left side, and end can be I minus I plus something, which is going to be len by 2. Okay, so this is going to update the start and end. At last we have to return substring s dot substring a start and end plus 1. Okay, okay, now we are going to implement expand from mid method. So for that, uh, we'll use a while loop. while left is while left is greater than equal to 0 and right is lesser than s dot length. This is the condition that we have to follow. We will make sure that it is not exceeded from the boundary, like left is not exceeded from the 0th index and right is not exceeded from the last index. Okay, and we have to check also that s dot char at left equal to s dot char at right, and we will keep moving left minus minus and right will be plus plus. So we are moving left and right side simultaneously. Okay, now at last we have to return right minus left plus, sorry, left minus left. So for like there is a case a b c b c a b c b a. So this is the left and right c index. Okay, we are moving two step behind and two step forward, so we have to consider the middle one also. So we are going to return left minus right minus 1. Okay, I think this should run. Let's see. Okay, return type we are not declared a, okay, so this will be private int. Yeah, the second. Okay, okay, let's run this and submit. Yeah, so we have submitted our solution. It is faster than 80.44%, and I think this is the one of the optimized approach. There can be other approach also, but we have discussed this approach in this video. So please make sure to like this video and subscribe the channel. Thank you.